Okay, here we go. New unit, factors and products. This is an extraordinarily important unit because you will be factoring, learning it as a skill in grade 10, be doing a lot of it in grade 11, and then it just becomes a tool. And in grade 11, it's a tool that you will use in order to solve problems. So factoring is the most important unit that we've done so far. So prime factors, we're going to talk about those. Greatest common factor, that's GCF, and least common multiple, or lowest common multiple, some people say. If a number has a factor, then the factor divides the number evenly. Well, I don't have a pen. Hang on while I grab myself a pen here. Give me a pen. Give me a thin-lined black pen. Okay, and then the factor divides the number evenly. Okay, so there'll be no remainder. If a factor must be a natural number, then list all the factors of 30. So factors are natural numbers, right? We don't do integers. We stick with the natural numbers, which, as we know, are the counting numbers, 1, 2, 3, 4, etc. So factors of 30, well, 1, 2, 3, not 4, 5, 6, not 7, not 8, not 9, 10, and you can sort of see now we're going to pair them up, right? 6 times 5 is 30, 10 times 3, so there's no point trying 11 or 12, so the next one will be 15, and then the last one will be 30. Okay, and you see how they pair up. 5 times 6 is 30, 3 times 10, 2 times 15, and 1 times 30. A prime number is a number that's only divisible by 1 and itself. Is 30 a prime number? Well, no, it's divisible by lots of numbers, 1, 2, 3, 5, 6, 10, etc. Is 1 a prime number? No. By definition, and I'm going to point you, this is Wolfram Math World. That's kind of the math site on the internet, and they'll explain here why number 1 is a special case, which is considered neither prime nor composite, and a bunch of explanation, but you can Google and look up whether or not 1 is a prime number, but it is not considered to be a prime number. So, which of the factors of 30 are prime factors? Well, 2 is a prime number. It's actually the only even prime number, right? Since 2 will go into every other even number, it takes them all out. 3 is prime. 5, not 6, not 10, they're even. Not 15, because 15 is just 3 times 5, and not 30. So 2, 3, and 5. List the first 10 prime numbers. Okay, so remember, we're starting with 2, 3, 5, not 6, but 7, no 8, no 9, no 10, 11, not 12, 13, and we keep going, 14, even, so skip all the evens, 15, no, 16, even, 17, 19, 21, no, 23, 25, no, 27, no, 29. That's our 10th prime number. So actually a fair number of them early on. The 2 is going to take out all the multiples of 2. The 3 will take out the 6, the 9, the 12. That was already the 15. Forget about 18. 2 took care of that. Took care of the evens. Takes out the 21. Takes out the 27. 5 takes out all multiples of 5, so anything ending in a 5. 7, and so on. Prime factorization. A number is factored if it's written as the product of 2 or more factors. Write the number 30 in as many factored forms as possible, using only natural numbers. So 2 times 15, 3 times 10, 5 times 6. Now, if we go on, we can write 6 times 5, but we'll consider these the same. So, 10 times 3, same. 15 times 2, same. 30 times 1. All of those are really repeats. Can we do anything new? Well, we could say, hey, 1 and 2. 2 and 15 is 3 times 5, so we could write 2 times 3 times 5. 3 times 10, but 10 is 2 times 5, so we can write 3 times 2 times 5. All right, we're not going to do all possible orders of this. We'll just say 2, 3, 5. 5, 6 can be 2 times 3 again, and so on. Which of the factored forms is the prime factorization? Well, this is the one that has only prime numbers, 2, 3, 5, and that makes it the prime factorization. Definition: the prime factorization of a number is the number written as a product of all of its prime factors. Examples: a tree is sometimes useful for showing the prime factorization of a number. So for example, we could write 60 as 4 times 15. But neither of these are prime. 4 is 2 times 2. Now this is prime, so I'm going to circle it. And 15 is 3, which is prime, times 5, which is also prime. So 60 is equal to 2 times 2 times 3 times 5. Each of these numbers are prime, so that is the prime factorization. Could we have started with another set of numbers? Well, instead of 4 and 15, sure. We could have started with, wait, this is embarrassing now. I need to go back up here and add 4 times 15. 4 times 15. Oh no, wait, that's 60. This is 30. Never mind. Okay. Could we have started with another set? Yes, we could have. Let's start with 2 and 30. See, now I was thinking of 30. So 2. Now 2 is prime and 30. Now I like to divide by primes where I can, so let's call this 2, or lowest prime. So I say, does 2 go into it? Yes. 15. Not prime, so we don't want to circle the 15. We want to uncircle the 15. And 15 is 3 times 5. So again, we get the same prime factorization. No matter how you start, that's what you're going to get. If you're watching this online, go to this link, www.bit.ly, which is just a shortened link, which will take you to Factor Down a Tree, a song about prime factorization, and I'll give you a little taste of it in a fullish screen. And basically just a little video on factoring trees. It's a few minutes long, and if you're in class, I will play it for you. Okay, so you've either watched that or seen it. We're going to move on now. Okay, let's talk about the greatest common factor. Write all the factors of 60. Okay, 1, 2, 3, now this time 4, 5, 6, not 7, not 8, not 9, 10. Okay, now they're going to pair up, right? So the next one will be 12, then 15, then 20, then 30, and finally 60. Write all the factors of 24. 1, 2, 3, 4, not 5, 6. Now you notice how 6 times 4. So we need 3 times 8. We need 2 times 12. And we need 1 times 24. The greatest factor that is common to both. So what's common? 1, 2, 3, 4. 1, 2, 3, 4. 6, 8. But we're looking for the greatest one. So let's start at this end. 24. Not over there. 12. Yes, it is. So the greatest common factor is 12. Therefore, 12 is the greatest common factor, right? The one that's common to both and is a factor, divides evenly in. The greatest common factor of 2 or more numbers is the largest factor. That is common to all numbers. Examples. Find the greatest common factor of 60 and 90. Okay, so there's a way to do this that's a little more mechanical. We can kind of look at it really and say, hey, 30 goes into 60 and 30 goes into 90, and I think that that's what it is. But the more what's the word? At a loss for word. The more mechanical method, or the way that will always work for you, would be to do the prime factorizations. Now we already know the prime factorization of 60, right? We did that on the other page. So let's go to the other page, and we know that 60 is 2 times 2 times 3 times 5. So let's go back here and write 60. 60 is equal to 2 times 2 times 3 times 5. Okay, let's do 90. Now you can write any factors, right? So I could say it's 3 times 30. 3 is prime. 30 is 3, which is prime, times 10. And 10 is 2, which is prime, times 5, which is prime. So 90 is equal to, now let's put these in order. So we'll go 2 times 3 times 3, 2 times 3 times 3 times 5. So that's 90. Now, in order to find the greatest common factor, we look at what's common. So we say, all right, 60 has a 2, 90 has a 2. 60's got another 2, but 90 doesn't. 60 has a 3, so we'll take a 3. Now 90 has another, but it's not reciprocating, right? So we got a 5 and a 5. So what we're looking at is the greatest common factor will be 2 times 3 times 5, which is 30. So our greatest common factor is 30. Okay, one more time. So we write the prime factorization of 60, the prime factorization of 90. We look for the common factors, and we write them down as many times as they occur in common. So in this case, we only have a 2, a 3, and a 5. And we multiply those together, and that gives us the greatest common factor. One more time. Let's try this with 200 and 630. So 200. Now, I like to be systematic. I think that's the word I was looking for earlier, was systematic. So I'm always going to try and divide by 2. When I can't divide by 2, I'll look, can I divide by 3? No. Okay, how about 5? Okay, 25 is 5 times 5. And you'll notice that I can't divide. That's 100. And that's 50. And 50 is 2 times 25. And 25 is 5 times 5. No editing out mistakes here, folks. What you see is what you get. So 200 is 2 times 2 times 2 times 5 times 5. 2 times 2 times 2 times 5 times 5. Now some people might write that as 2 cubed times 5 squared. And there'd be nothing wrong with that, but well, let's move on to 630. I'll give myself some room up here. 630. So 2 prime. 2 goes into 630 315 times. Probably not prime, especially because it ends in a 5. But does 3 go into that? So 2 doesn't, this isn't even, but 3 does. And 3 goes into this 105 times. And how do you know? You just take 315, divide by 2. Nope, divide by 3. Yep, 105. Is 105 prime? Probably not, because we know that 5 goes into it. But does 3? And 3 does go into it, and it goes in 35 times. 35, not prime. We know that 35 is 5 times 7. So 630, where am I going to write this? How about here? 630 is 2 times 3 times 3 times 5 times 7. Now, one advantage of the expanded form is I can say, okay, we need a 2. Do we have any more 2's? Not in common. We got a 5 though. Got a 5. Do we have any more 5's in common? Because all this is, 200 is just 2's and 5's, and the answer is no. So our greatest common factor is 2 times 5, which is 10. So the greatest common factor of 200 and 630 is 10. The least common multiple. Some people say lowest common multiple. The least common multiple of a set of numbers is always the smallest number that all the number, so we need the smallest number that all the numbers in the set divide into evenly. So it's a multiple of the numbers. So let's write some, with, and again, no remainder, right, evenly. Write some multiples of 60. 60 times 2 is 120, 180, 240, 300, 360, and more. Multiples of 24. 24 times 1. And we're talking about, natural numbers multiplying. 24 times 2 is 48, 72, 96, 120, 144, 168, and so on. The least common multiple that's common to both. Now, when I look for least common multiples, I always look at the bigger number, and I say, okay, 60, do you see it over here? Nope. Okay, 120. Is that, yes, it is. So the lowest common multiple that's common to both 24 and 60 is 120. That is the least common multiple. It's the smallest number that all the numbers divide into evenly. So 24 goes into 120, 60 goes into 120, and it's the smallest number that they both go into, right? And again, I always start with the bigger number because these multiples are going to be further apart. Okay, we know that if we kept going, 240 is going to be in here, right? Because 24 times 10 is 240. But we want the lowest, the least common multiple. Therefore, 120 is the least common multiple of 24 and 60 because it's the smallest number. They both divide into evenly. The least common multiple for 2 or more numbers, okay? Doesn't have to be just 2 numbers, right? If we're adding fractions, we need the least common, we need the lowest common divisor, which is really the least common multiple, is the smallest or the lowest. It's the smallest multiple that is common to all of the numbers. Okay, so basically one way to do it is just to list multiples of every number and then look for the smallest one that is common. But there's another way. A more systematic, now that I've got the word. So we could just start writing down numbers, right? We could go 20, 40, 60. No, wait a sec. I said start with the big number. So let's go 25, 50, and say, is it divisible by 20? No. 75. Nope. 100. Yes, 100 is divisible by 20. And we can see if we keep going that, yeah, this will be the lowest common multiple. Not very systematic, though, but sometimes faster, right? If we're looking, but let's come up with a way that's a little more systematic. And the way we're going to do that is we're going to do a prime factorization. 10 is 2 times 5, circle, circle, right? When you've got all of the numbers, the factors are prime, then you circle them because you can't go. 5 isn't anything other than 1 times 5. And 25 is 5 prime times 5 prime. So what do? We look at this and we say, I need this 2, and I need this 2, and I need this 5, and I've got 2 5s here, so I need one of them. Just think, this one's common to both, so we write our lowest common multiple consists of a 2 times a 2 times a 5 times a 5. So we just see how many times does the factor 2 appear, and we take the most number of times it appears. So 2 appears twice, 5 appears twice. It's 2 times 2 times 5 times 5, which is 25, 50, 100. And that's the systematic method. Find the least common multiple of 30 and 45. So again, if I were just doing this kind of in my head type thing, I would say 45, nope, not divisible. 90, yes it is. Okay, 90 is it. But again, systematically, we are going to factor down a tree. 3 times 10. 10 is 2 prime times 5. So you can see we're going to need a 3, a 2, and a 5 in here. 45 is 5 times 9. 5 is prime. 9 is 3 times 3. So my lowest common multiple, I need the 2. I need 2 3's. So times 3 times 3. That's what I mean by 2 3's. And I need the 5, right, which is common. And the most number of times that 5 occurs as a factor is once in each. And the most time that 5 occurs, or 2 occurs as a factor is just this one time here. So we're not including both of these 5's because they both have, we just say it's in common. So we say we need a 2, we need 2 3's, we need 1 5. 2 times 3 is 6, 18 times 5, that's too hard. So 15 times 3 is 45, times 2 is 90, and that's kind of the one we figured out, but this is a very systematic way of doing it. Okay. And of course you must practice. Jane loves counting money and arranging coins. She wants to make rectangles using 40 pennies. One rectangle is shown. Now of course you might not know what a penny is. Well, at some point they won't know, but what is the length and width of all the other rectangles that can be made using all of the 40 pennies for each rectangle? So we could just go 1 and arrange 40 in a row, right? So we could say 1 times 40. If we did it as 2 together, then 1 times 40, then this would be 2 times 20. We can also do 4 times 10. We can do 5 times 8. Now if we consider this the width and this the length, then we could reverse all these numbers. But a 5 times 8 rectangle is really the same as an 8 times 5 or an 8 by 5. So 20 times 2, 40 by 1. So I don't think I would count these. They're simply just the length and the width flipped around. How do these answers relate to the factors? They are the factored form of 40. And it's the factored form that can be made up with 2 numbers because we want a length and a width. So I don't want to write it as 2 times 2 times 2 times 5, which would be the prime factorization, because I only have a length and a width. So I want to write it as all. How does it relate to the factors? It's all 2 number factorizations. So that is, if we are going to write it as the product of 2 numbers, then it's all 2 number factorizations of the number 40. Find the GCF and the LCM for 30, 15, and 75. Okay, easiest way to do this, factor tree. Circle the 2. 15 is 3 times 5. These are prime, so we're done, right? We can write 30 is 3 times 5, or 2 times 3 times 5. 15, 3, and 5. Factored pretty easily. 75, 3 prime times 25. Composite. If the number's not prime, it is composite. Or it's 1. Special 1. Okay, now to do the greatest common factor, we need factors that are common. So we say, hey look, it's got a 3, this has a 3, this has a 3. So for the greatest common factor, 3. Notice the 2. This has a 2, but it's not common. And what else is common? Well, this has a 5, this one does, this one does. Now, if they had 2 5s, well, you know, we'd consider. But we've got 3 times 5, which is 15. The lowest common multiple says we need everything that's here. So I need a 2, I need a 3. Okay, I got the 3, and I need a 5, and actually I need 2 5s, so I need a 2. I need 1 3, and I need 2 5s. So this handles it, 2 3 5, right? Is that in there? Yes, it is. This is 3 5. Is that in there? Yes, it is. And this is 3 times 5 times 5. Is that in there? Yes, it is. So each of these factorizations has to appear here in the lowest common multiple. 5 times 5 is 25, times 3 is 75, times 2 is 150. That will be the lowest common multiple. Could do it, right? There's multiple choice. You just say, well, 75 is my biggest number, so 75, 15 goes into it, but 30 doesn't. Okay, let's go to the next multiple. 150 goes in 10 times, goes in 5. Yeah, 150 would be the lowest common multiple. Write the prime factorizations and find the GCF and LCM of 196 and 248. Now, this for sure is where you do not want to be sitting there and trying to multiply these out and say, okay, 248 and times 2 is 496, and does that go in? And, you know, if I want the greatest common factor, then what, you know, so we do really want to go systematic here. So 196 is 2 times 98. 2 is prime. 2 goes into 98. 2 is prime, and it goes in 49 times. 49 is 7 times 7. So the prime factorization of 196 is 2 times 2 times 7 times 7. 248, divisible by 2. You don't have to start with 2. You could say it's divisible by 4 and then break the 4 up. I just like to be systematic. 248 divided by 2 is 124, which is divisible by 2. 62 times, which is divisible by 2. 31 times, and that's prime. So 248 is 2 times 2 times 2 times 31. So the GCF, remember the way we do greatest common factor, is we look for things that are common. So if this says a 2, it's got 2 2's. This has 2 2's. So 2 2's are common. This has a 7. This doesn't. This has a 31. This doesn't. So it's just 2 times 2, or 4. The largest common factor of 196 and 248 is 4. GCF. LCM. So remember, we need everything. So I need a 2 times a 2 times a 7 times a 7. So I need 2 times a 2. But wait a sec. I need 3 2's. I need 2 times 2 times 2. Then the 2 7's times 7 times 7, right? So I need every times 7 times 7 times, I need everything that's there, and that will be a 31. So this requires calculator, and the answer is 12152, 12,152. And good luck finding that if you're just going to start taking multiples of 248. So what may work well for numbers like 30, 15, and 75 for finding the LCM will not work well for numbers like 196 and 248. And that's why we need this more systematic method of doing this. There's a stack of rectangular tiles with each tile having a length of 84 centimeters and a width of 63. If some of these tiles are arranged into a square, then what is the side length of the square? Okay, so if you think about it, I have this tile which is 84 by 63. And I'm going to lay this tile which is 84 and again 63 wide. So what I really need to know is how many 84s and how many 63s does it take to make a square. Okay, so really what we're asking is, what is the lowest common multiple, right? These would be multiples of 84, 84, 2 84s, 3 84s, and so on. So we need the least common multiple of 84 and 63. Now I could start taking multiples of 84, but at some point it's easier just to say, hey, let's factor down a tree. That's 2, this is 42, 42 is 2 times 21, which is not prime. And 21 is 3, which is prime, times 7, which is prime. And 63. Here I'm going to do one. It's 9 times 7. And 7 is prime, but 9 is 3 times 3. So 3 times 3 times 7. So for the lowest common multiple, we need a 2. You know, what do we need? We need 2 2's, 2 3's, and 1 7. So it's the greatest number of, right? So this has 2's, but this doesn't, so we need 2 2's. They both have 3's. We need the largest number of them, so it's times 3 times 3. And they both have 7's, and the largest number of 7's is 1. So we get 2 times 2 is 4, times 3 is 12, times 3 is 36, times 7 is 210, and 42 is 252. Now, if you want to know how big is this, well, there are 3 84s in 252, and there are 1, 2, 3, 4. There are actually 4, so this would make your square, right, if we filled this all in. Because this side length here, these 4 guys, is 252, and these 3 guys here, crossing them out, is also 252, right? So the lowest common multiple, and if you wanted to figure that out, you go 252 divided by 84 to say which multiple of 84 is it? It's 3, and 252 divided by 63, which multiple? It's 4, so that this square is made up of 3 by 4 arrangement of these tiles. Too far. A fence is being constructed with posts that are 12 centimeters wide. A second fence is being constructed with posts that are 15 centimeters wide. If each fence is to be the same length, what is the shortest fence that can be constructed? So I don't know if these are posts or boards. I think they're probably more boards that are 12 centimeters wide. So what we need to know is, okay, how many 12s and how many 15s? You know, really I need the least common multiple, right? So if I do 15 by itself, I can lay out a 12, but then I'll have 3 left over. If I do 2 15s, that's 30. That'll fit 2.5 of these, and so on. So we need the least common multiple of 12 and 15. So 12 is 2 times 2 times 3. And 15 is 3 times 5. And the LCM is 2 times 2, 3, which only occurs once, and 5, which occurs once. So that's 4 times 3 is 12, times 5 is 60. So the shortest fence that can be constructed, the shortest fence that can be constructed is 60 centimeters, or centimeters if you're French. A box of sugar cubes has a length of 156 millimeters, a width of 104, and a height of 39. What is the edge length of one sugar cube? Assume the box is completely full and the manufacturer uses sugar cubes with the largest possible volume. So basically what we're looking for here is the largest number that goes into all three of these. And the largest number that goes into all three is called the greatest common factor. So we need the GCF of 156, 104, and 39. So let's factor 156 is 2 times, so just take a calculator, go divide it by 2, 78. Take a calculator, divide by 2, 39. Take a calculator, divide by 2. That doesn't work, so divide by 3, 13. 13 is prime, so we're done. 2 times 2 times 3 times 13. 104. Take a calculator, divide by 2, right? If it's even, it's going to divide by 2, and this is even, so it's going to divide by 2. And this is even, so it's going to divide by 2. And 13 is prime. 39 does not divide by 2, but it's 3, which is prime, times 13, which is prime. So the greatest common factor. So what's common? 2, not 2. 3, not 3. 13. So the greatest common factor is 13. That's the number that will go into all of these. So 156 divided by 13 is 12. 104 divided by 13 is 8. And 39 divided by 13 is 3. So this will be 12 sugar cubes long. Okay, so here's the cubes, right? So there'll be 12 of them. It will be 8 wide, and they will be stacked 3 high. And that will give you the largest possible volume that fits into this, with each cube measuring 13 by 13 by 13 centimeters. And that ends our first day of factors and products.